So here we're supposed to find the vector equation that goes through AB. So let's first find our directional vector. So from A to B, 4 to 5, it's going up by 1. 6 to 3, it's going down 3. And it passes through AB. So we have two different vectors we could use for our positional. We could use 4, 6 plus W times our directional vector, or S or T. It doesn't matter what variable you use, or R equals. It passes through B as well, so we could use 5, 3 plus W times 1, negative 3. So our next one, it passes through A, so that means our position vector has to be 4, 6, and it has to be perpendicular to BC. Well, BC, 5 to 8 is 3. 3 to 6 is negative 3. And it has to be perpendicular. So that means our vector here, that dot product with this has to equal 0. So 3x minus 3y has to equal 0. So x could equal 1 and y could equal 1. So 3 minus 3 is 0. But there's many different options here. So there are other options as long as that x and y value give you a dot product of 0. So find a vector equation passing through V and parallel to AC. So passing through B. So that means it has to be 5, 3 plus W, and it's parallel to AC. So AC is 1 and negative 3. Oh, sorry, AC. A to C is 4 and 0. So this would be 4 and 0. Now this next one, number 10. Alright, here we go. Word problem. Let's see if we can figure out what's going on. All distances are in meters and time in seconds. An insect is flying at a constant height. At time 0, the insect intersects at point A with coordinates 0, 0, 6. 2 seconds later, the insect is at point B with coordinates 6. Excuse me, sorry about that. Negative 2 and 6. Find AB. Well, 0 to 6 is going up 6. 0 to negative 2 is down 6. 6 to 6 is 0. Show that the position vector of an insect at time t is given by this vector. Well, let's see. Well, here's our position vector. So, 0, 0, 6. Well, if this is 2 seconds later to get to here, what would our position vector be for 1 second? Because it says t is in seconds. Well, if this is 2 seconds, is 6, negative 2, 0. 1 second would have to be 3, negative 1, 0. So our position vector would be, or that's our directional vector, 3, negative 1, 0, because that's how fast it's moving per second. And then it passes through our A coordinate, so we have 0, 0, 6. So that's how they get this 3, negative 1, 0, because it's per seconds. So letter C here. At time t, at t equals 0, a bird takes off from the ground. Right, the position at the bird is this. Write down the coordinates of the starting position. Well, that would be right here. So it starts at 36, 18, and 0. On this next page, it says find the speed of our bird. Well, this is where it's moving. So our speed, how fast it's moving, we take the square root of all that. Negative 3 squared plus negative 4 squared plus 1 squared. Because what we talked about on day 5, that's our velocity right there, that constant velocity. So we have 16 plus 10, so the square root of 26 meters per second. And let's see this last bit for this one. The bird reaches the insect at point C. Find the time it takes the bird to reach the insect. So we have our insect of 0, 0, 6 plus t times 3, negative 1, 0. We want to know when it reaches our bird, which was 36, 18, and 0, plus t times negative 3, 4, and 1. So we have all these systems. We have 0 plus 3t, and actually there's only one variable here, which is nice. So there's our x, our y, 0 minus 1t, and then we have our z, 6 plus 0t equals 0 plus 1t. So now we have to solve. Well, let's see, if we just take this first one, there's only one variable, so 3t equals 36 minus 3t plus 3t. 6t equals 36, so t equals 6. So they intersect after 6 seconds. And then we're asked to find the actual coordinate. So if we plug that in, x equals 0 plus 3 times 6. So x is 18. Y is 0 minus 1 times 6, so y is negative 6. And z is 6 plus 0 times 6, so z is 6. So it intersects at the coordinate 18, negative 6, and 6.